All right, so awesome talks before me. We're still talking about road mapping and execution. I'm going to take a slightly different angle at that. First of all, everything Joe and Nick said before me, make sure you do that and listen to them, because it's all true. I'm going to take a different angle at this. I'm going to talk about the software architecture angle. In other words, you've got a roadmap, you have all this cool process in place to execute on it, and now you have to make a series of technical decisions about what your stack's going to look like, what database you're going to choose, what language you're going to use, a string of technical decisions you're going to have to make on the first day of the project and then going forward to make all of that cool stuff possible. And if you're that person, then how do you do that, basically? How do you do that? How do you make that possible? What are the mistakes to avoid? And I want to ask a question. Who here listening to this is thinking, yeah, that's me. I'm the guy, or the gal. All right, and who's thinking, so in other words, who's thinking, it's my job at whatever project I'm working on right now to make those technical decisions. I'm the architect. All right, we've got a few architects. And who's thinking, I work with the architect, he reports to me, or I report to him, or he's busting my balls in meetings, or something like that. Okay. Should have broken that down in different categories. And who's thinking, oh, Lord, please help me find that person? Who's actively hiring? OK, a few people. All right, so this is relevant to all of you, I think. So the question is, OK, how do I make this possible? And I'm the founder of a company called dotCloud. We help developers deploy and scale their applications. And our claim to fame is we make that possible for a lot of different stacks. So we work with developers who use all sorts of those stacks, and the question comes back a lot, which is, what should I choose? How should I go about it? So it's kind of a specialty of ours to have that conversation. And so this is me bringing my experience as a founder, having had to make these decisions and deal with their consequences, and also watching a lot of different developers and architects and business leaders kind of live with the consequences of those decisions in their respective projects. And so, let's find out if there are patterns there. So the first thing to talk about here is what your goal should be. How do you measure success? You're the architect, you're in charge of those decisions. What should you be aiming for? And I think really you should be aiming for three things. The first, and Nick said that, and actually everyone's saying that, you got to go fast, right? It's all about shipping the product as fast as possible, not just the first time, but iterating on that, getting feedback from your customers, adapting the product, shipping that new feature, fixing bugs, whatever it is, you got to go fast. It's a race to the death. There's a competitor just behind you trying to do that before you, so you got to go fast. And as the architect, your job is to make that possible. So you don't want to slow down the rest of the organization. The second goal is scale, right? You're going to launch a product or relaunch a product or whatever. At some point, the plan is either to be featured on an app store or in another, get that peak of visitors. You're planning for success, right? And one thing you're trying to avoid as the architect is on that fateful day where that peak hits, everything goes down because you didn't plan for it. So you want to avoid that. And the third thing you want to plan for is making your products future-proof. So things change over time, business requirements evolve, you're going to learn new things from those customers that you shipped things to, and you're going to have to change. Your team's going to grow or your team's going to shrink. You're going to acquire or get acquired. Things are going to move very fast. And Nick talked about technical debt earlier. The last thing you want as you adapt to those changes is to hear engineers say, well, we can't actually do that right now because we've got to refactor and clean all that mess up. So you want to avoid that. So these are really the three things that you're trying to get: speed, scale, and a future-proof architecture, right? So what are the patterns in getting there? So the first thing is there's no perfect combination. There's no silver bullet of a perfect stack, a magical tool, or a magical method that will give you a straight A in all three, right? It's always a trade-off. And that's, first of all, you got to admit that. And you got to realize that if someone's telling you, here's a perfect solution that will make you incredibly fast, incredibly scalable and incredibly future-proof, guarantee, then they're selling you something, or they don't know what they're talking about. And you should know that. Question those assumptions. The second thing to know is that that trade-off is going to evolve over time. Right? It's not the same trade-off on the first day when you have no proof of value to anyone, and you're out there going to launch, you got to figure it out. Your priorities then are not the same as after launch. You've got a set of users, you're trying to find out if they're staying, and not the same set of priorities as a year later when you've got customers and you're trying to figure out how to get them to pay you more or respond to a new entrant in the market, whatever. So be aware of the fact that there is a trade-off, number one, and the trade-off is going to evolve over time. So revisit your assumptions. Be very careful to not just set them in stone and just leave them there and just assume they're never going to change. Because that's a mistake. Well, it's a mistake we've made a lot. But we've seen a lot of people make it, and I think it's a classic mistake. And the third consideration here is that the trade-off is also different from team to team and from practitioner to practitioner. Everyone has a bias. If you're writing code or you're involved in shipping product in any way, you've got a bias towards one of those priorities. And maybe you think that's not true, but it definitely is. And if you don't know it, I assure you people who work with you, or at the very least your customers know what it is, or they'll find out soon enough. So the sooner you find out what your bias is and embrace it and accept it, the sooner you can self-correct in finding the right trade-off. I'll give you an example. Actually, I'll give you two examples. The one typical case is the over-engineering team. You got brilliant engineers. They've got years of experience. They've done web-scale systems all their life. And here you are working on this new project, and they're going to make sure this thing never goes down. I mean, it's never going to crash ever. Also, that's also never true, but that's probably for another conversation. And that's their bias. You're there. Maybe you want to ship something as fast as possible, especially if you haven't launched. Maybe it doesn't matter if it crashes at 1 million users on the first day, because guess what? You're not going to have 1 million users. And you're going to have that conversation with that team, and they're going to say, yeah, we know, but then they're going to go back and they're going to do it anyway. So make sure as a team, as an organization, you're aware of that bias, and you admit it. You say, okay, that's our bias, and I'll tell you what, it's our bias. We've known it forever. The dotCloud started in 2008. We're a bunch of systems engineers, infrastructure engineers. We've launched and then relaunched in 2010, and I mean, we had to force ourselves to do the very basic things like get something in front of the user that they could use. We just would delay shipping forever because it was not rock solid enough, not scalable enough, you name it. And the way we overcompensated, and by the way, I give a lot of the credit for getting us on that path to Y Combinator. We were part of a batch in 2010. We just couldn't launch. It wasn't ready, right? It's going to crash. Something's going to go wrong. And at some point, we just kind of gave ourselves a day and said, "Screw it, we're launching whatever it takes." And the short version of our platform is you write code, you send it to our platform, we deploy it, and it works, right? So we had all the "it works" part, but we didn't have the "you ship us the code" part. So once you got the code to us, it would be perfect, but we didn't actually implement that part where the UI for the developer to upload the code, right? Because the rest wasn't ready. And so we gave ourselves that date, and 1 week before that kind of date we gave ourselves to get over our bias, we didn't have that. So we forced ourselves, swallowed our pride, and went to that first list of 20 early adopters, convinced them to use us, and said, it's going to work, it's going to be perfect. How do I upload the code? Well, just email us a tarball for now. And they did that, and they were very happy with the rest. So we had this very embarrassing UI for the first couple of weeks. But embarrassment, by the way, is a huge motivator. Put yourself in a situation where you're embarrassed, your team's embarrassed, and things are going to start happening faster. Anyway, so know your bias. There's also the opposite bias, right? It doesn't matter if it works. We're going to ship. We got all these features, and that can happen if maybe your team's very business centric and there's less regard for engineering quality. That can happen. Or maybe you've got a team of engineers who have been burned by the previous bias in a previous company. also got to self-correct. There is no right answer. It's just whoever you are defines what that bias is. Just keep it in mind and correct for it. Anyway, so these are the three. I would say, main goals, the main things to watch out for. Another key consideration is who that person is. And actually, I'm a little worried because you guys are all involved in some sort of startup or shipping product in some way. I mean, you're here, right? And to tell the truth, in all the categories I listed of how you're involved with this person responsible for making those technical decisions, I didn't see all the hands go up. And so my question is, maybe you don't know exactly who that person is or should be, and make sure you do. And maybe you're thinking, well, I'm in a big team. We're all kind of collectively responsible for those decisions, and that is a great situation to be in. That's what you want. You want the whole team to be the guardian of those shared values, what these priorities should be. But usually you get there by having someone early on who's the owner of that and develops that culture and then communicates it to new members of the team as they are hired. You need that person. And for those of you who are working on a project and outsourcing a lot of the technical work, make sure that that role stays in-house. Don't outsource the key decisions on your architecture. Don't outsource those key decisions. You're going to regret it down the road. You want to keep ownership of that. Right. And that, well, maybe I'll keep that for off-the-record conversations, that example. All right, so now I had a whole list of recommendations on how to achieve that, right? Because I didn't actually give you very practical tips. A lot of the tips I wanted to give you were actually mentioned already, so make sure you automate, make sure you shorten the cycle to ship, make sure you keep communication as asymmetrical as possible. Those were all said before and you were paying close attention, so I don't need to repeat it. Awesome advice. From a more technical point of view, the one thing I would add, when you think about the architecture, the actual technical architecture, think in terms of services. I strongly recommend mapping your entire technical organization, the whole code base, the whole set of functionalities, and map it as a set of services that communicate with each other over the network. Loosely coupled components, each in charge of a specific feature, of a specific functionality, and they talk to each other over APIs, right? They don't share data, they don't share much. They're separate, they're concise, they're reusable. Think through the whole architecture in that way, and that is, we've found, and a lot of our customers have found that is a very useful framework for organizing and for addressing all the future decisions you'll have to make, right? And this is not like a groundbreaking thing. I'm sure everyone uses some sort of cloud service for some of the functionalities. I mean, I use Twilio to send text messages. I use Mailgun for email, all that stuff. I'm saying architect everything as a service, whether you're developing it or someone else is. Right? You probably are doing this already if your application is cross-device, right? Because some of your functionality has to be used from a mobile app, from a web app, so you're kind of forced to do that. But believe me, this is going to help you in all of the areas I talked about. It's going to help you ship faster because you're going to be able to reuse components where you don't differentiate, and that could be components from a third-party company. So hey, I can use text message service from Twilio, great example. But maybe you can reuse components from inside your organization, right? Maybe there's another team that's been building services, and hey, you guys have features in common. Reuse that. Maybe it's your team, and you're launching a second version, or you're branching out a specialized product. I don't know. Reuse components from there. So having that architecture allows you to make those decisions. It also helps you scale and not go down when you are featured, because it helps you break down the problem of scaling. Scaling is a hard problem, and if you break it down functionally, now you're free to worry about scaling each piece separately, right? And a key principle of service-oriented architectures is if you're writing the service, you're in charge of running the service. So the team who knows the code chooses the servers, chooses gets paged at night if it breaks. They think about the data model and all those hard problems, but they don't have to worry about how it interconnects with 1,000 different other services. They're worried about their service, so it's easier for them to deliver. So that's also going to help you. And lastly, we talked about making your product future-proof, right? Being able to adapt to future changes that you can't plan for. I mean, you don't know ahead of time what they are. You just know they're going to happen. Service-oriented architectures help you with that too, right? Because again, it's a framework for making decisions, right? Hey, we need to bring this piece back in-house because we need to control the data, or this vendor is too expensive at our scale, so let's switch vendors, or bring our own version, build our own version. You can do that more easily if that component you're talking about is a separate component in the first place, as opposed to, oh, I guess if we want to do that, then we have to rip it all out, and I guess it's a different code base, so yeah, let's do that later, right? Same thing for that technical debt problem. Hey, we can't ship that because we need to refactor this piece of technical debt. The nice thing about services is they isolate technical debt, right? The team building the storage service, has that schedule. They're going to get around to refactoring this piece, but not quite yet. That does not affect the team building your credit card management service or your push notification service or whatever. It does not affect them. Actually, they can use different languages. They can make different technology choices. If you're acquiring a small team that specializes in that has a totally different stack, you can incorporate them without having to have these big meetings where everyone kind of fights over which language should be the standard for your organization, all that stuff. So this is my advice, really, in a nutshell. Think about what your goals are as an architect. And actually, even before that, find out who the architect is. Otherwise, yeah, no need thinking about that. And then, keep in mind all the advice you heard today and measure whether they work or not based on those goals, right? Don't rush and apply 1,000 different best practices you just heard about if you can't measure whether they work or not. So keep that measure of success in mind. And then my personal contribution, that list of things to do, is from a technical point of view, architect in terms of services. Big companies have been doing it forever. The tools are there. You guys can do it. There's no reason not to do it. And one last thing, in how you do that, what tools to use, what methodology, what standard, what language, there is no silver bullet for that either. And this is coming from a vendor, right? Our job is to help developers do that. So if I'm telling you we're not the silver bullet for doing that, no one is the silver bullet for doing that. Pick and choose, do your homework, figure out what the pros and cons are of each platform and set of tools. But one way or the other, I urge you to think in terms of services. You'll benefit from it in a lot of ways. And yeah, that's my little contribution. Any questions or claps? Yes. Oh. There you go. Great.
No, I mean, I loved how you mentioned the two different biases on the extremes, as far as, won't release anything until it's perfect, all the way to the other end. And I'm curious, you said there's no right or wrong, but I'm curious on that thought, especially you're saying after going through Y Combinator and then kind of helping, you understanding the bias, but then still being able to kind of force out of it. It would seem like that the middle ground would be that perfect, whatever that is. It's like that's what you want to achieve for it, but it's like, I mean, you said there isn't. I'm curious, is there really? It seems like there's a trade-off, right? Because I admittedly am, my bias is another, and I want to fail fast and fail often, almost to a fault. It's just like, does that shit not work? Fuck it, ship it. Then the other side, I managed teams where their bias was, I don't want to ship this until 10 years later. But there seems to be trade-offs. On my end, it seems like we would end up going back and fixing things and losing business value. On the other side, you're holding on to it. You're not getting any money because you're not shipping anything. So it seems, I'm curious on if you can extrapolate a little more.
Well, I think when you're talking about shipping faster, that's not a bias. That's a net positive, right? If you're shipping faster, if you're getting value to customers faster, then then that's good. It's always better, no matter what the situation is. I think You know, it depends on a lot of things. It depends on what kind of a product you're shipping. To give you an example, in our case, we run people's apps, right? So if we ship a feature that, you know, faster, but it happens to cause, you know, crashes in half of the applications that we run, then the net value to the customer will be negative, right? So sometimes there are constraints associated with what kind of a product you're shipping. You know, actually, one trick that I've seen work a lot is when you have a situation where something in your product is really business critical, but maybe it's not the whole thing, right? You can separate. You can isolate between the key infrastructure, business critical part of your product and the part where it's okay if, you know, the button doesn't click for a few minutes because you shipped too fast. You can correct it. Not the end of the world. So you can break things down like that. I think that the key consideration is, you know, when you have that bias of, you know, I don't care, just ship it now. The danger is when that comes at the expense of long-term customer value to the customer, right? Where you're kind of exposed to the risk of you and the customer being paying for that speed down the road. Like, it doesn't work. It's shipped, but it doesn't work. But not caring, right? And what you're saying seems like a more balanced approach where, you know, I'm recognizing your bias. As an engineer, you want your work to be perfect before you ship it, but I'm telling you, you know, from the point of view of my experience as someone responsible for shipping product, it's good enough. Let's go, you know. So I don't know. I feel like I'm not really answering your question. It's a moving target. Yeah. But I will say this: if it is a very valuable thing in a team. When a team starts knowing itself and gets better at finding that balance and staying on target, that usually means the team is getting more experienced, and that is something that's very, very hard to replicate. I mean, that is a differentiating advantage if you can get a team capable of doing that again and again. Yeah. Thanks a lot.